then add it to the W to get another vector. Or you can say add the V equals the W, get a vector, and add that to the U. Hopefully you'll get the same thing. If you don't, you are doing something strange. What do we call this? Associativity. Now the physicist is like, what are you talking about? Right? Right? I know what I want to do. What does the physicist want to do? Anybody? What does the physicist want to do? The physicists want to say, well, now if I'm here in Mississippi and I want to go dollar casino, dollar bill casino, and here's my boat, and you've got a thrust, and then here's the river with a drift. What do I need to do? Hopefully that's not a flood. Now, the physicists say, hey, if you're going to go straight here, you go whatever is dollar bill, you end up in the jail, huh? The physicist says, I need to add these things correctly before I go to the casino. I know what I'm doing. I don't know what you mathematicians want to call addition, blah, blah, blah. Your thrust, your drift, and the result. The physicist says if you add the thrust to the drift, the result should be this. That's how I add vectors. Now, whether it's associativity or commutativity, I don't know. But this is going to do the trick. Now, we all know what physicists do. They have 1,001 forces in this mind. They want to know, what is the result? If you add them all up, what is the result? Is it this?
Probably not from all of that.
I don't know, but you have to do it correctly. So let us talk about that. Vector addition. So we have a vector u. Oh, one scalar multiplication I forgot. This is u. What is it giving? You keep magnitude, but you won't know the direction. Okay, here's v. We would like to know what is u plus v. Oh, by the way, I'm doing this in 2 dimensions. But there's no reason not to talk about things in 3 dimensions, huh? Here's a vector. Here's a vector. Add them up. 3 dimensions. Now here there's no algebra, so there's nothing to prevent me talking about it. All I'm doing is saying, scale a vector. Here's a vector. Here's one of those. Here's a vector. Here's twice. Now, we want to say, what does u plus v equal? Miss Yasmin, how did your pre-calculus professor talk about this? Bring them tail to tail. Bring them tail to tail. What next, Miss Yasmin? Go along u and then add v. That is to say, slide the v up. Slide the v up. Make the v a little longer. Make the u a little shorter. Go along u, slide the v up, parallel, started here. Let me see what the result is. That vector there. That is to say, if you are aiming your airplane to Reykjavik, Iceland, and the wind is blowing you to the Arctic, you're going to end up in Moscow. I'm sorry? Now, clearly this is correct from a physical point of view. The question becomes, is it correct from a mathematical point of view? It is. If you do V plus U, what do you get? You go V, then bring the U here. Get the same thing. It is most certainly commutative. So you say to yourself, you say to the physicist, you've done some good mathematics as it happens. You've done some good mathematics. And then of course now you can, by the way, what is U?
A vector.
What is V? What is U plus V? This is what we mean by vector addition. Take one vector, add it to another vector, and you will get another vector. So, now we can start playing around, right? We can start playing around. We can say, well, this is U, and this is V. We can say, what is U minus UV? So what we'll do is we'll say, form the vector U, form the vector V, then form the vector 3V, then form the vector that is in the opposite direction, and then add them up. Very good. That is the algebra, the geometric quantity. You can certainly then do additional three or more vectors. So here's a vector U, here's a vector V, and here's a vector W. If you want to do U plus V plus W, how would you do it? You would say, well, take the U and add it to the V. Who doesn't know how to do that? And you will get a, take that vector and add it to the W. Like the last in middle school, okay. Add 2 plus 3, 5. Well, add 2 plus 3 plus 5. Say, well, add the 2 plus the 3, 5. Well, add the 5 plus the 5. Right. Associativity. Trust me, it works.